You guys all ready for a workshop? Woo, all right. Well, let's give a warm welcome to our next presenter, Tony Roman with Cacti.
Thank you. Today's essentially a workshop. Larry's covered some of the stuff if you were in the other Cacti presentation, so I'm kind of going to go through that. But basically, today we're covering implementations in large installations. So most of you probably know, but today we're going to cover what is Cacti, the origins of Cacti, large installation considerations, automation, the current state of Cacti, the future of Cacti, and then we'll have a question and answer at the end. What is Cacti? Cacti is the complete front end for RRD tool. I assume that everybody in here is pretty much familiar with RRD tool and what its capabilities are, so we'll kind of gloss over that. It's written in PHP and has an optional C-based polar called spine. We store all necessary information for creating graphs and gathering data in a MySQL database. It has full support for SNMP and the ability to use custom scripts for gathering data. So you can pretty much gather anything you want, similar to Nagios and the concept of plugins. And we have a very large user community that has created pretty much a template for anything you can conceivably think of is probably out there. If it's not out there, you can make it. Origins of Cacti. So Cacti was started in 2001 by Ian Barry as kind of a high school project. He worked for a local ISP at the time called PANet, and he developed it for PANet and put it out there as open source. It's a free application that's published on the RRD tool website, and it's pretty much how a lot of people really have found it. One of Larry's lines, discovered by many in search for replacement for pretty much you name it. Excuse me. Before 2004, Ian released a few releases. Larry, what was it, 6 releases? Not many. It wasn't that many before 2004, but it was a pretty active project. And widespread global use began after the 086 release in summer of 2004 when myself and Larry joined the team. So, large installations. There's a lot of considerations to be had when it comes to large installations. And first, is the hardware. I can't say it enough, and a lot of people may disagree with me, but the more hardware you throw at it, usually the better off you are. There's always budget and costs involved, of course. So when it comes to CPU, the more the better. The more cores you got, the more parallel you can do. It really depends on the number of devices and data sources being pulled. Now, in Cacti, there's this concept of a data source. A device has multiple data sources, and each data source basically comes down to, for example, if you're pulling a switch, a data source is every metric that you pull on a port. So the traffic in and out is a data source, and the errors is a data source, the discards, example of errors, unicast, multicast, those type of things are all considered data sources. So the number of data sources depends on how many metrics you're graphing per devices, and it depends on your network. If you're just doing networking equipment, it can be rather high. If you're just doing servers, it can be rather low. The more concurrency, the better. And the only reason for that is there's a lot of processes going on in Cacti, and not only is there the polling aspects for gathering the data, but there's the graph generation and the web serving, as well as the database that is involved in that as well. Other considerations, memory. Excuse me, I need to get a drink. Again, the more the better. There's lots of considerations with memory, and one that I don't think most people think about is if you increase the amount of memory on the host, consequently you'll increase the disk cache. And one of the major issues with RRD is that it's very intensive on disk I/O. And if you increase your read-write cache in the operating system is going to help you because it's going to cache those reads and those writes and then sequentially write out the data to disk, giving you better disk I/O. You can also need more memory allocated in MySQL depending on how much you're doing, and some other things we'll talk about later, like potentially moving your polar table into a memory hash table, which can greatly increase your performance. Disk I/O. I cannot stress disk I/O, disk I/O, disk I/O, disk I/O. Anybody who does anything with disk I/O is your major issue. The process of actually updating the RDs is pretty intensive. RD is relatively good about doing in-place sequential writes to the files, but it is still a lot of information to be written to disk at once. And the way Cacti's Polar works, if anybody's familiar with it, typical Polar cycle is 5 minutes. So all your data gets gathered, and then it systematically starts writing out the data to RD files as soon as it can. And during that time, if you're not using some other technology that we're going to talk about, your machine can come literally under responsive because of the amount of disk I/O that's being pushed. Again, more CPU, more memory. The more I/O operations per second, the better. Again, you can increase your memory to increase your disk cache, which will help. My phone is ringing. You can also increase the number of spindles in a RAID configuration. I hope that everybody's familiar with RAID, but the more spindles you throw it at, the more disk I/O you can typically get. Your best configuration, of course, is RAID 10. Mostly because you're looking at writes as your primary issue for RD. Fiber channel and storage or SAN, storage area networks, with appropriate RAID level configuration are also very helpful, as long as your SAN's not over provisioned. And I think anybody who deals with a SAN can understand those aspects. Solid state drives, and Fusion I/O, PCI Express non-volatile memory storage solutions are a good alternative. You can also supplement those with like a RAM drive, for example, if you have enough RAM on the host. And I've had a few large installation customers do things like write the RDs to either a Fusion I/O device, which is very fast. If anybody's familiar with them, it's basically a PCI Express solid-state hard drive. It does not use SATA. It's right off the bus, so disk operations per second. Larry, you have one customer utilizing it. It's like 300,000?
800,000 4K block writes per second.
Yeah, it's astonishingly fast, but it's also expensive. The solid-state drives are also a good choice too, but you have to be aware that you are going to be reading and writing data a lot, and the mean time to failure on solid-state can be a concern for the amount of cycles you're going to be writing. No. So examples of disk I/O success. We had one person Larry and I were working with that they were unable to complete their polling cycle, 5-minute polling cycle, 160,000 data sources in 5 minutes, to completing it less than a minute when using a Fusion I/O. That's alone, just investing in a Fusion I/O card and storing the RD tool files on there. And there we go, at a Fusion I/O speed, write speeds of 3.2 gigabytes per second. That's pretty amazing. I haven't seen SANs go that fast. So other considerations is service separation. Cacti has some major components. And those components are the web interface, which is PHP, Apache, or Nginx, or whatever your choice is to make PHP work. There's many, many, many different ones. The polling and RD storage typically are put together in the database. Any of these services can be split over to another server. So you could split up your web interface on its own server, as well as your polling and your RD storage and your database. The web interface does need access to RD tool files because it's got to generate the graphs that our customers or your users are looking at. So typically you can either utilize CIFS or NFS, some sort of network file system, to access those files. You can use a shared LUN on a SAN. There's many options there. Replication, you can copy them. It depends on what your need for update is if you decide to do replication. And then one thing I'm not familiar with, but I know exists out there, is disk SAN, shared volumes and or file system type replication stuff that you can utilize. MySQL optimizations are pretty important when it comes to the polling cycle. And the reason for that, and we'll get into it, is that the poller, when it's running